This video is going to be about EZ configuration assignments. For alkenes. So this is going to be similar to RNS assignment for tetrahedral chirality centers, tetrahedral stereocenters. So again, stereocenters is the more generic term. Chirality centers is specifically for the sp3 hybridized tetrahedral stereocenters. Okay, so for that, we use the Conning-Gold Prelog rules to assign ranking. And here we're going to assign rank the same way by highest atomic number. And that'll be at the first point of difference going out from the vinylic carbon atoms. Now, one big difference is that instead of comparing all four groups that are attached to an alkene, let's say, for example, we have dichloroethene. And in this particular one, we already know that we would call this cis, but we want to also know how to assign it as E and Z. And so we have here the two vinylic carbon atoms. And what we want to do is we just want to compare the next two atoms out attached to the vinylic carbon atom on the right and decide which one is higher ranked. And then we're going to do the same thing to the carbon on the left. So compare each set of atoms attached to each vinylic carbon atom. Okay, so here, chlorine versus hydrogen. Chlorine has the higher atomic number. So we're just going to circle whichever one has the higher atomic number when we are comparing with the vinylic carbon atom. And then we're going to look at the vinylic carbon atom on the left, and it has a chlorine and a hydrogen also attached. So chlorine is the higher atomic number there. And the way we're going to assign E and Z, E stands for Entgegen, which I believe means opposite in German. And so that's going to be what that means. But I'm going to remember it as being either. Basically, we're the highest ranked group. Is on either side of the pi bond. Okay, and then Z stands for Zusammen, which I believe means together in German. But the way we're going to remember it, unless you know German, is that these are going to be on the same side. Okay, so the highest ranked group are on the same side of the pi bond. All right, now this, I will admit, is a little confusing because, to be honest, E is going to look more like a Z if you're just looking at the image. So you really have to just use the word and not think about the shape All right, I just want to caution you against that because I think that makes it easy to get mixed up. So this one would be E because the higher ranked groups are on either side. I'm so sorry. This is not cis, this is trans. I apologize. And here, these two, if we had the other stereoisomer, this would be actually the cis, and this would be Z, where the highest ranked groups are on the same side. And again, the shape here looks more like an E, so you've really got to just use those mnemonics. All right, let's look at another example where we couldn't use cis or trans. Okay, so here we have a CH3 and a hydrogen. So the first atom is a carbon versus a hydrogen. So carbon's going to win that. All right, and then here we have carbon versus chlorine. And so, of course, the chlorine's going to win that. And since these are on either side of the pi bond, this is going to be E. And if we needed to name this one, we have a 1, 2, 3, 4, 5 carbon chain. We have a chlorine at the 3 position. So this would be E3 chloro pent 2-ene. All right, and we would be able to draw the structure from that name. If we had the other stereoisomer, we were to swap either set, we would end up with the other stereoisomer. So again, chlorine is higher ranked than carbon. Carbon is higher ranked than hydrogen. So here these are on the same side, so this would be the Z. Still 1, 2, 3, 4, 5, 3 chloro pent 2-ene. Okay. All right, let's do at least one more example just to get more practice with this. Okay. Here we're presented with a tie on the right side. These are both carbon atoms. So then we need to go to the next set of atoms out. And this carbon atom on the top has a sulfur, a hydrogen, and a hydrogen. This carbon on the bottom has a carbon, a hydrogen, and a hydrogen. So that sulfur is going to have a higher atomic number than carbon. And so this group is going to be the higher ranked group because of that sulfur versus that carbon. On the left, we have a carbon and a carbon. So again, we have a tie initially. The carbon on the top has an oxygen double bonded, so we're going to count that as oxygen twice, and a carbon. The carbon on the bottom has a carbon, and a carbon. All right, so the oxygen atom is going to win that contest and have the higher atomic number. And these are on the same side, so this would be Z. And we haven't really done thiol nomenclature, so I'm gonna just leave this one and not name that one. I wouldn't give you one quite this complicated. But that's how we do E and Z nomenclature. So just remember that Z is Zane, where the higher ranked groups are on the same side of the double bond. Not attached to the same vinylic carbon atoms, but on the same side of the pi bond. And E for entgeigen, meaning across, is going to be on either side.